Okay, this video is about how to verify identities. So you're going to be making one side of the equal sign look like the other. That's the goal. So here's some tips to help you. Number one, work with one side of the equation at a time and start with the more complex side. Generally, that helps the most, starting with one side only. Number two, look for things like factoring, adding fractions, substitutions, or other things like that to help simplify the problem. Number three, always try to put things in terms of a sine and a cosine. Number four, try something. Do not stop, just try something. All right, for example one, I'm going to actually work it two different ways to show you that you can get to the same place two different ways and both are correct. All right, so here's way two, here's way one. All right, so I'm just going to write it out. Secant squared of theta minus 1 divided by the secant squared of theta. Now, some of you are thinking, can't I just cancel out the secant squared theta? No, you cannot, because that one on the top is connected to that minus 1. It is not a Lone Ranger that can be canceled. So the first thing I would do is look at my identities little card, cheat sheet, and think about, is there anything I can substitute in here? Well, there is one identity that has secant squared in it, and it says this. This is 1 plus the tangent squared of theta equals the secant squared of theta. Alright, it's not exactly what I have here. However, if I subtract a 1 from both sides, I will get that. I'll have tangent squared of theta equals the secant squared of theta minus 1. Now this will match, and I can replace all of this on top with the tangent squared. So that's what I'm going to do. Tangent squared of theta over the secant squared of theta. Now what I want to do is replace both of these with sines and cosines, the equivalent of in sine and cosine. So for tangent, that means it's the sine squared of theta over the cosine squared of theta. That's tangent. Divided by secant squared. Well, that's the reciprocal of cosine. So I can write it as 1 over cosine squared of theta. Now I have to divide fractions. I have to do keep it, change it, flip it. Okay? So the sine squared of theta over the cosine squared of theta times, flip the bottom. These will cancel, and so my final answer is sine squared of theta. So if there's not an equal sign, you're just trying to simplify, right? There will be some with equal signs. So that's one way to solve this one problem. Now, if I'm going to work it a different way, you could basically separate out these fractions like this. So the secant squared of theta over the secant squared of theta minus 1 over the secant squared of theta. All right, so all I did was separate out the fractions with the common denominator. Now, this can be reduced to 1. This, 1 minus secant squared, remember reciprocal properties. Secant's the reciprocal of cosine, so I can write this as cosine squared of theta. Now, it's not looking like the left side, but we're not done. What do you know that has cosine squared in it? Well, remember your Pythagorean identities. If I rearrange this and move my cosine over by subtracting cosine squared, I'm going to get sine squared of theta equals 1 minus the cosine squared of theta. That is what I have, and I can then replace it with the simpler sine squared of theta. Now, the two ways to work it look the same. I got there two different ways. Both are correct. You just want to get it to the simplest form you can. All right, here's a true verifying equation because there is an equal sign, and I want to make one side equal to the other. Now, yes, there are fractions, and yes, you may have to add fractions. In this case, you do. We need to be able to add these two fractions, but in order to do that, you have to get a common denominator. So think of these denominators as different factors, okay? They're different because one's a plus and one's a minus, all right? So to get a common denominator, I'm going to have to do 1 plus the sine of alpha times 1 minus the sine of alpha. And to get that common denominator, I have to multiply this one this first fraction by the 1 minus sine of alpha. Okay, that gave me my common denominator on the bottom. On the top, I'm going to have 1 minus the sine of alpha, plus, over here I need the common denominator that we said. So on this side I have to multiply by 1 plus the sine of alpha, on bottom and top. So on top I'm going to have 1 plus the sine of alpha. Alright, so hope that makes sense. We just did common denominators, that's all we did here. Now, let's simplify this. Because this is a plus sign, I can really drop the parentheses here and simplify this out. So what happens is I have 1 plus 1 is 2. Minus the sine of alpha plus the sine of alpha, those will cancel each other out. So I end up with just a 2 on the top. On the bottom, you should recognize that these are difference of squares. The first terms are the same, second terms are the same, one's a plus and one's a minus. So I can rewrite this as 1 minus the sine squared of theta. Alright, now I'm trying to get it to secant. Remember, secant's related to cosine. So what can I do with cosine? Well, remember your Pythagorean identities. Again, remember the sine squared of theta plus the cosine squared of theta equals 1. Well, I need sine squared to sine squared. So if I subtract sine squared from both sides, that goes to 0, and then I have cosine squared of theta equals 1 minus the sine squared of theta. Alright, so I'm going to replace all this in the bottom with cosine squared. So 2 over the cosine squared of theta. Now, break this down. That's like saying 1 times the cosine squared of theta times 2. Well, there's a reciprocal. Hopefully you recognize that's a reciprocal. That's secant squared. So I would have secant squared of theta times 2, which is 2. And that, it's not theta, it's alpha. My bad. It should be alpha. That is what I needed it to match. That is what on the right side of my equation. Sorry, I switched from alpha to theta, but the variable doesn't matter, really. Alright, let's try another example. Tangent squared of theta plus secant squared of theta equals 2 secant squared of theta minus 1. Now sometimes you kind of need both sides of the equation, because you notice in this one you have a secant squared here and a secant squared here. So I want to combine like terms like algebra teaches me. So let's do that first. We're going to subtract secant squared of theta from both sides. And then this is just 1 secant squared of theta. So what I have is tangent squared of theta, what left. So that's 2 minus 1, so that's 1 secant squared of theta left minus 1. Now, look at your trig identities chart. See if there's anything you can replace with to simplify even more. What you find is that you have the tangent squared of theta plus 1 equals the secant squared of theta. Okay, those are related. We need to make it look like one side or the other. Alright, go with the simpler side. I want it to look like tangent squared. So in order to do that, I need to subtract 1 over here. Tangent squared of theta equals secant squared of theta minus 1. Did I get this over here matching what I have in the original? Yeah, these match, so I can substitute. Tangent squared of theta equals tangent squared of theta. And that's what I need it to be. I need the two sides to match. Alright, I want you to try this one for class on your own. Yeah, I know it's a lot to think about, but just follow the steps. Remember, follow the steps that you know. Don't get overwhelmed. Start by just replacing with sines and cosines and reducing. See what happens, okay? Don't get overwhelmed. Just try it, and we will see what happens tomorrow in class.